Hello, wonderful viewers. Today I'm talking about the topic matrices of some special linear transformations, and I'm focusing on reflection. Special linear transformations include we have translation. Translation involves a shift or movement. Then we have rotation, and rotation involves turning or rolling. And we have reflection. Reflection involves a flip or objects in a mirror. Then we have enlargement. Enlargement refers to expansion. What is a reflection? A reflection or a flip is a transformation that is defined by its line of reflection or mirror line. To draw the reflection, first draw the mirror line. What do we do next? Then draw perpendicular lines to the mirror lines from the vertices of the object shape to that of the image shape. So we can see a typical example. We have object shape and image shape and a mirror line directly in between them. Take note of the perpendicular lines. Examples of reflection. Let's consider triangle T. When we reflect shape T in the line x equal to 2, so we need our mirror line perpendicular to the x-axis, passing through x-axis at point 2 and parallel to the y-axis. So image distance should be the same as object distance. Object distance should be the same as image distance. So we have T image. So that is reflection in the line x equal to 2. And then reflect shape T in the line y equal to x. So we need our mirror line, that's our mirror line y equal to x. Don't forget, object length equal to image length. Distance from the object length to the mirror line equal to the length from the mirror line to image. Image length equal to object length. So we have our second image of T. That was examples of reflection. Now reflection, the general formula for a matrix A under a reflection is given by A equal to cos 2 theta sin 2 theta sin 2 theta negative cos 2 theta. To remember this formula, let's see that cos 2 theta is on the leading diagonal and sin 2 theta is on the other diagonal, where theta is an angle between 0 degrees and 360 degrees inclusive. Angles in the Cartesian plane. From the diagram, reflection in the y-axis. What is theta? Now we know y-axis is vertical line. So what is theta? From the Cartesian plane, theta equal to 90 degrees. Reflection in the x-axis. What is theta? Theta equal to 0 degrees. Reflection in the line y equal to x. Let's observe theta. Theta equal to 45 degrees. Then reflection in the line y equal to negative x. Theta equal to 135 degrees. Matrices for reflections in the coordinates plane. The general formula for a matrix A under a reflection is given by, let's remember ourselves of our formula, A equal to cos 2 theta sin 2 theta sin 2 theta negative cos 2 theta. Reflection in the x-axis, we all know that theta equal to 0 degrees. We substitute that in our formula. So we know that 2 times 0 is 0. So cos 0 sin 0 sin 0 negative cos 0. The resulting matrix will be 1 0 0 negative 1. Now reflection in the y-axis. What is theta? theta is 90 degrees. And we already know that 2 times 90 degrees is 180. Substituting in our formula, we have cos 180 sine 180 sine 180 negative cos 180, and our resulting matrix is negative 1 0 0 1. Matrices for reflections in the coordinate plane. Reflection in the line y equal to x. What is theta? Theta equal to 45 degrees. Substituting that in our formula, we know that 2 times 45 is 90. So we have cos 90 sine 90 sine 90 negative cos 90. When we work that, our resulting matrix will be 0 1 1 0. Reflection in the line y equal to negative x. What is theta? Theta is 135 degrees. And we know that 2 times 135 is 270. Substituting in our formula, we have cos 270 sine 270 sine 270 negative cos 270. When we work that, our resulting matrix will be 0 negative 1 negative 1 0. Reflection in the line y equal to kx. For this one, we have to divide through the equation by x. So we get y over x equal to k. And we know y over x is the gradient, so which is the same as tan theta. So tan theta equal to k. So to find theta, tan moves to the other side of the equation, giving tan inverse. So theta equal to tan inverse of k. Example 1. Find the image of the point 3, 4 under the transformation by a reflection in the line y equal to negative x. Let's look at the solution to example 1. Let the transformation matrix be S and the reflection in the line y equal to negative x. Let the transformation matrix be S, and for reflection in the line y equal to negative x, theta equal to 135. So we know 2 times 135 gives us 270. So from our formula, cos 270 sine 270 sine 270 negative cos 270. When we work that, our resulting matrix will be 0 negative 1 negative 1 0. So once we have our matrix, we use the formula image equal to matrix times point. So image equal to the matrix 0 negative 1 negative 1 0 times the point 3 4. When we multiply, we have row by column. First row by the only column, which is 0 times 3 plus negative 1 times 4. And the second row times the only column, which is negative 1 times 3 plus 0 times 4. Our answer is negative 4, negative 3. Therefore, the image of 3, 4 is negative 4, negative 3. Example 2, question A. Write down the matrix P representing a reflection in the line y equal to 0. Question B. Find the image of the point negative 2, 1 under the transformation of a reflection in the line y equal to 0. Solution to example 2. Looking for the matrix, we know that reflection in the line y equal to 0, another name for that is the x-axis. And reflection in the x-axis, our theta equal to 0. We know that 2 times 0 is 0. So we have cos 0, sin 0, sin 0, negative cos 0. So our resulting matrix is 1, 0, 0, negative 1. Image equal to matrix times point. So looking for the image, we multiply our matrix by the point in the question. So 1, 0, 0, negative 1 times negative 2, 1. So row by column. First row times the only column in the point. So we have 1 times negative 2 plus 0 times 1. Then second row by the only column in the point, we have 0 times negative 2 plus negative 1 times 1. Our answer is negative 2, negative 1. Therefore, the image of negative 2, 1 is negative 2, negative 1. Example 3. Question A. Write down the matrix M representing a reflection in the line y equal to root 3x. Question B. Find the image of the point 3, negative 2 under the transformation of a reflection in the line y equal to root 3x. Let's look at the solution. We divide through the relation given. The function given was y equal to root 3x. We divide through by x, and so we have y over x equal to root 3. And we know that y over x is tan theta. So we have tan theta equal to root 3. So theta equal to tan inverse of root 3. So theta equal to 60 degrees. From our formula, we have the matrix equal to cos 2 times 60, sin 2 times 60, sin 2 times 60, negative cos 2 times 60. But we know 2 times 60 is 120. So we have cos 120, sin 120, sin 120, negative cos 120. When we simplify, we get the matrix minus 1 over 2, root 3 over 2, root 3 over 2, 1 over 2. Let's continue with our solution. Now that we have our matrix, we use the formula image equal to matrix times point. And our image equal to the matrix we had, negative half, root 3 over 2, root 3 over 2 half times the point given in the question, which is 3, negative 2. From our multiplication, we use row by column. So first row by the only column of the point, so minus half times 3 plus root 3 over 2 times negative 2. The second row by the only column, root 3 over 2 times 3 plus half times negative 2. Our answer is negative 3.232, 1.598. Therefore, the image of 3, negative 2 is minus 3.232, 1.598. Thank you very much for your time. God bless you.